Alright, hi everyone, thank you for coming. Today, I'm going to talk about the cost of modularization. My name is Aldo, I'm currently working at Astro. Astro is a quick commerce startup in Indonesia where our customers can purchase groceries and essential items and will send those items in less than 30 minutes. Before we talk about modularization, I think it's important to know a little bit about the modularization itself. Modularization is the act of breaking down one module into multiple Gradle modules. In this presentation, I use the term module and project interchangeably. So when I said module, this also means multi-module, this also means multi-project. There are three reasons why we use modularization. One, faster build time. By using Gradle build parallel build feature, we can achieve faster incremental builds and faster clean builds. 2. Modularization encourages reusability. Since the module is broken up into multiple modules, we can import a module like a library. And then 3. Clear ownership. Typically, modularization is implemented in a company where there are many engineers. The engineers can form a dedicated team to work on a set of modules or functionality. So Team A can focus on module related to payment, Team B can focus on modules related to libraries, and so on. Of course, there are implications of implementing modularization. Modularization adds complexity to our project. Therefore, we should spend more time and effort to solve the challenges or costs. This is what we are going to discuss in this presentation. Toys app is a project that I will use throughout the presentation to demonstrate some of the concepts you'll see later on. The code sample that you'll see is simplified. If you want to see the implementation detail, please check the source code of Toys app in the GitHub repository. Toys app is a simple app that has 3 screens: main screen, toy screen, and payment screen. From the main screen, we can navigate to toy screen. In the toy screen, we can navigate to the payment screen. So we can navigate between the payment and toys screen. This demonstrates the navigation between feature modules that we will discuss later on. Okay, without further ado, the cost of implementing modularization. We will discuss what are the costs of modularization, when we will encounter the problem, and how to solve it. Cost number 1, organizing modules. As I said in the previous slides, modularization means breaking down one module into multiple modules. This can happen when we start a new project or adopting modularization in the late stage of development. The problem is, if we did not define the clear boundary, we don't know how to organize our modules. We will encounter questions like, how many modules should we create? What's inside a feature module? Should a repository goes in the feature module? If we don't know how to organize our modules, we may end up creating too many modules. This can lead to unnecessary complexity. Or not creating enough modules so that we don't gain the benefit of modularization like faster build speed, reusability, and clear ownerships. The solution to defining the boundary is to decide the app architecture and module convention together with your team. There is no straightforward answer for organizing modules. It depends on many factors. It depends on your project requirements, your team size, the libraries that you'll use. For this cost, you really have to make a consensus with your team. But in general, we can define how to organize module by defining the app architecture, like MVVM and MVI and so on. Then we should also create the module convention, like app module, feature module, or library module. This helps us define what's included and not included in the module. Lastly, we should also define the relationship between modules. In this presentation, I'll share the examples of how we organize our module. For our first example, this example is taken from Android developer documentation. The Android developer documentation preferred app architecture is model view, view model. As you can see in this picture, the view module is inside a feature module. There are home view model in home feature module, reviews view model in reviews feature module, and so on. And a feature module can define on a data module where the actual work is happening. Let's move on to the data module. The data module contains the repository. This repository can delegate the actual work to the implementation classes. In this picture, there are book local data source that talk to database, book remote data source that communicate with the server, and payment play data source that I assume talk to Google Pay API. And this is the complete graph of the project. From this graph, we can see that there are 4 types of modules: app module, feature module, data module, and core module. This graph is a directed graph, so the arrow means one-way relationship. App module can depend on a feature module, but not the other way around. Same thing with feature and data module relationships. Lastly, the core module is at the bottom of the graph. And the core module can't have dependency to the app module, feature module, and data module. This is the second example, Now in Android. If you're not familiar with Now in Android, it's a project that Google team used to demonstrate Jetpack Compose and, most importantly, modularization. Let's see how Now in Android organize their modules. You can see the similarities with the example 1, right? However, there are 3 types of modules instead of 4. We have app module, feature module, and core module. That's it. The difference is the data module is merged with the core module. I assume Now in Android team makes this decision because the app features are limited. They don't need to create a dedicated data module for each feature. If you look closely, the core module can talk to other core module. I think this is fine because there is no cyclic dependency where 2 modules depend on each other. And finally, the Toys app. In this project, there are only 3 types of modules: app module, feature module, and library module. I make 2 types of library modules though, JVM and Android library, since I find that some library don't need to depend on Android framework at all. There is no data modules either, because this app does not communicate to the server or database. Yep, that's it. This concludes cost number 1. For the second cost, which is enforcing module convention, now that we have decided our app architecture and module convention, we should enforce it in our project. When we create a new module, we need to ensure that the module follows the module convention. For example, if we create a new feature module, we need to make sure that it uses the same plugins and libraries as another feature module. Also, when we update a module configuration, the changes should be reflected in the same module type. And lastly, we should make sure that the module can only depend on a certain module type. Of course, we can do it manually by copy-pasting the configuration, but there is a better way, by using Gradle plugin. We can use Gradle plugin for storing our module convention. This is commonly called convention plugin. The module convention plugin contains module configuration, like setting, dependencies, plugins, and so on. To make sure the module has correct relationships, we can use this cool plugin called the Module Graph Assert. It's created by Joseph Raska. First of all, we need to create a project to store our plugin. Let's call it Build Logic project. After that, we need to create the plugin. A standard plugin that looks like any other Gradle plugin, where you have to implement the plugin interface. And finally, register that plugin so that our module can apply this in the build.gradle. Let's use feature module in the Toys app as an example. In the Toys app, the feature module is using Compose. Currently, there are only 2 feature modules, but if you want to add a new feature module, we can configure it faster with convention plugin. There are other module types as well, like application, JVM library, and Android library. But for this example, we are only going to create a convention plugin for feature module. This is the current feature modules build.gradle. We have the standard plugin block, Android block, and dependencies block. We will extract the default config and compose first. That's inside the Android block. As you can see in this code, it looks similar to the code in the build.gradle, right? We pass the min SDK to the default config block, and we also pass the Kotlin compiler extension version in the compose option block. There are not many differences. And then, after moving the default config and compose option to the convention plugin, we're left with the plugins and dependencies block. Next, let's move the remaining code to the plugin. Here, we are using plugin manager's apply function to apply the plugin, and the dependencies block for adding module dependencies, like JUnit and Espresso. Again, the code is also similar to the build.gradle, isn't it? Finally, this is the final code of the build.gradle. We just need to apply the plugin ID in the build.gradle, and our module will conform the feature module type. If we want to add a new code, if we add a new code in this build.gradle, the changes only apply to this particular module. If we want the changes to apply to all feature modules, we should modify the plugin instead. Okay, next we will see how we can enforce module relationships using the module graph assertion plugin. From this Toys app graph, we can infer the following rules. The app module can depend on feature module, but not the other way around. The feature module can depend on the library module, but not the other way around. And feature module cannot depend on other feature modules to avoid cyclic dependency. To enforce these rules, first, we need to set up the plugin. As you can see, we are using convention plugin for our app module to add the module graph assertion plugin. We then formalize the rule that we have decided in the previous slides. We allow the app module to depend on other feature module. Feature module can depend on library module. After that, we restrict the feature module to depends on another feature module. And also, library module cannot depend on the feature module. Okay, let's test our rule by making the payment module depends on the Toys module. In the payment feature build.gradle, we add the Toys feature as a dependency. When we try to do that and execute this task, assert module graph, we will get an error, because the feature module is not supposed to depend on another feature module. The plugin also will nicely show the reasons for the error. It says feature payment is not allowed to depend on feature toys. If we remove the previous code and run the task again, we'll get a successful build. Note that this plugin has another feature that might be useful for your project: the task that can generate a module graph. Just run the generate module graph with text task. Let's conclude cost number 2 and cost number 3, dependency management. Managing dependencies in a multi-module project can be tricky. If we add an external library to our project, we need to ensure that the library with a different version does not already exist. Also, if we have many modules in our project, let's say 100 modules, it would be nice to search it quickly without worrying a typo. We can use Gradle's version catalog for managing dependencies across modules. We can do so by adding libs.version.toml file to the Gradle folder. If we want modules in our project to be accessible by other modules, we can use Gradle's typesafe project accessor. To enable it, add this code in the settings.gradle. And this is the example of the version catalog's toml file, where we have version section, library section, and bundle section. You can put a library version in the version section. In the library section, we also put the artifact and group name. In this example, I want to use compose library for our module. We can declare compose version that we want to use under the version section and refer the compose version in the version.ref. Version catalog also supports bundling multiple libraries. To use Jetpack Compose libraries, typically we need to specify these 4 libraries. We can just refer to one bundle instead of typing libraries 4 times. And this is how you use the version catalog's libraries. Just use the libs followed by your library or your bundle name. Notice that the coin library definition is converted from using dash separator to dot separator. In this code, we add the compose as a bundle. We can also use version catalog for test implementation scope. By using version catalog, we are confident that our modules are using the same library version. Feature modules is using the same compose version 1.2.1, and library modules is using the same JUnit version. Okay, typesafe project assessor. Just look at this code sample and you'll find it's pretty self-explanatory. If you enable these settings, you can access the module by using projects followed by your module name. However, unlike version catalog, Gradle will generate the projects automatically, so you can just use this in your project right away. Okay, cost number 4, dependency injection. This is yet another common scenarios in a multi-module project, where you need an instance of a class or an interface, but the implementation of the class or interface is not in your module. To illustrate this problem, we have the payment activity that wants to get an instance of a logger. The implementation of logger, whether console logger or logcat logger, is not in the payment activity. Payment module only have dependency to the logger library. So how can payment activity get an instance of a logger? We can use dependency injection for this. I'm using coin as the DI library. The secret is to make the app module to have access to all modules in the project. Since the app module has access to all modules, the app module can construct the instance definition. Or we can create module in the app module. Or create coin module in the feature or library module. It does not matter since the app modules still have access to that coin modules. As you can see in this graph, app module has dependencies to both feature module and library module. Next, we just need to wire them up together. And this is how you do that in coin. First, you need to create the module in the app module. Inside that module, we declare the console logger. as the implementation of logger. Then you just have to pass the module to the main application. If you have coin module in the feature module, you can also refer this in the main applications, since again, the app module also has access to the feature module. And lastly, the consumer, the payment activity, will receive the instance of logger that provided by the app module. The last cost number 5, navigation. This is yet another common scenario where the activity needs to call another activity and vice versa, but the problem is the activity is in another module, similar to what we encounter in the problem or cost number 4. Also, if you still remember our graph rule, the feature module cannot talk to another feature module. We have enforced this using plugin, right, in the cost number 2. In this code, toys activity needs to call payment activity, but the payment activity does not exist in this toys module. Again, toys module cannot declare the payment module as dependency. Sounds familiar? Yes, we can use the same dependency injection technique. I call this technique intent provider, since it's providing an intent to the consumer. Another name for this is mediator module. You'll see in a moment why it's also called mediator module. Okay, let's get back to basics of Android development to explain this intent provider. To start an activity, we can use an intent. Now let's ignore the payment activity for a moment. If we can somehow create an intent, we can start an activity. Now we just need a way to provide that intent. I use this interface called payment intent provider to do that. The interface itself only has one function, get payment intent. That function has 2 arguments, a context and an arbitrary argument. This intent provider class lives inside the library module called navigation. And both feature module can make a dependency to this module. By doing that, feature toys and feature payment have access to the payment intent provider. Navigation module is the mediator between feature toys and feature payment. Get it? Hence the name mediator module. The toys activity is the consumer of the payment intent provider. But which module will implement the payment intent provider? That's right, the payment module will implement the payment intent provider. Why? Because payment module has access to payment activity. And the rest is straightforward. Just construct the intent by passing the payment activity as the second argument. The intent now can be consumed by the toys module. One more thing. How can toys module can get an instance of the payment intent provider? We can use dependency injection for this. Remember that the app module has access to all modules? Well, we can define the definition of payment intent provider in the app module. Now the toys activity can receive an instance of payment intent provider. That's it. There are other solutions for navigation. For another activity to activity navigation in a multi-module project, we can use implicit intent with a package name. To do so, just use the action name in the Android manifest file, and when you call the intent, don't forget to pass the package name. Since in the Play Store we are guaranteed to have a unique application ID, we are sure that only our app can open this intent. And for single activity architecture, we can use deep link. Deep link is just a string that you define in the navigation graph. For example, this string called toys_fragment. Yep, that's pretty much it. When should we use modularization? When you and your team have time and effort to pay the cost, which we just covered in this presentation. To summarize, you need to organize your module by defining the app architecture and module types, enforcing module convention by using convention plugin, using version catalog for dependency management, using app module for dependency injection, and use intent provider for navigation. That's all, folks. I hope you find this presentation useful. Thank you for watching.